Hello, geometry students. For today, we will be tackling the second part of Standard 11. You will need in-class 47, and we're just going to work through the first 2 pages of that, and then we'll come back in another video to talk about the second 2 pages. So yesterday, or whenever you were in class last, we worked on simplifying these radicals using a variety of methods. Our starting point today is just to make sure that you remember how to do that. If you'd like to pause the video and try those on your own just to make sure you've got it, you're more than welcome to. My suggestion is that you always start by trying to type in the radical to see if the calculator simplifies it because it's a perfect square. But then if that doesn't work, we've got various methods that we can use, one of them being a factor table, where we divide 80 by larger and larger numbers to give us smaller and smaller numbers to try to square root. That first set of factors still doesn't work. 80 can't be divided by 3, so if we bump it up to 4, we'd have 4 and 20 next, but the square root of 20 still doesn't give us an integer answer. If we do 80 divided by 5, we'll make it to 16, which is going to be perfect because the square root of 16 does simplify. So basically, we're rewriting 80 as a radical with a multiplication problem. If you are somebody who uses the perfect square method, this is the work your teacher is expecting to see. And then that root 16 becomes 4 and leaves the root 5 behind as a multiplier. So the simplified answer for square root of 80 is 4 square root 5. We can try the same thing with the second problem. Square root of 117 is not an integer because 117 is not a perfect square. So another option, if you're not a factor table or a perfect square person, is a factor tree. So I'll use that method to remind you on this one. 117 cannot be divided by 2 because it's not even. So if we try to divide it by 3 maybe, sure enough, 3 and 39. When you're making a factor tree, you can use any pair of factors you want. So if you had thought of a different one, you could have started in a different place. 3 is prime, so I'm done working on that, but 39 can be divided by 3 again to give you 13 and 3. And then 3 and 13 are both prime. So we've made it to the point where we have all prime numbers. This factor of 3 matches. And so if you're doing the factor tree method, what you're looking for is a matching factor. That's going to become the coefficient. And anything that doesn't have a matching factor will return and be the root. So the square root of 117 simplifies to be 3 root 13. We have 2 other algebra skills that we're going to need to remember for some of our problems today. And so just as a reminder, if we're asked to simplify a binomial squared, or anything squared, we need to remember to multiply that binomial by itself. That's really what squaring means, which means we have 4 x times x multiplication problems, x times negative 3. There's 2 of the multiplication problems. And then negative 3 times x, there's the third multiplication problem. And then negative 3 times negative 3 is the fourth and final multiplication problem to get all of that distributing to occur, to multiply those 2 binomials together. We've got some like terms here in the middle. So x squared does not combine with anything, but negative 3x minus 3 more x is negative 6x, and then plus 9. We'll do the same thing with this one. So we'll multiply x plus 7 by itself, which means our first multiplication problem is x times x for x squared, then x times positive 7 times x, and positive 7 times positive 7. We've got like terms again here in the middle, so our final answer for this one will be x squared plus 14x plus 49. Now, because I think it's important for you to see why, here's the most common mistake when it comes to a problem like this. Sometimes people think that they can just square the 2 parts. But if I just square the 2 parts, I'm only going to get the x squared, which matches, and the 49. And I'm always going to miss out on this middle term. So this shortcut is not a shortcut. It's actually an incorrect way of doing that problem. So when you're squaring a binomial, we're always going to multiply it by itself to get the 4 multiplication problems and then combine like terms. All right, why are we doing all of these things? Well, in Standard 11, we are going to learn something called the Pythagorean Theorem. And the Pythagorean Theorem can be used in all 5 of these triangles. So if you look at what they have in common, they all have a right angle. It just happens to be in a different location in each one of these pictures. And so what happens when you're dealing with a right triangle, which we always will be, is that we have a formula, c squared equals a squared plus b squared, that will always describe the relationship between the 3 sides of the shape. It's very important that we make a careful decision about what c is. That's why I write that formula with the c up front. C is going to be the triangle's hypotenuse, which should be familiar from our work first semester with something called HL, hypotenuse leg. And then A and B are exactly the other part of that thing we used to use. They are the legs of the right triangle. So just as a quick recap, in case you've forgotten, the H is always across from the right angle. That's where we'll put the C for our Pythagorean theorem problems. So if we travel across from that right angle, we're always finding our way towards the hypotenuse of the triangle. And that is the most important decision when it comes to using Pythagorean theorem. After that, the A and the B can flip-flop. They're interchangeable because they are both legs in the triangle. So either of the green sides could be A, and then the other one is going to be B. So I'm just going to mark that I turned those legs green, I turned the hypotenuses pink, and so that means I can choose. I could make this the A and this the B. I could make this the A and this the B. Or I could flip these, and I could be 100% correct, even if you put your A's and B's in different places than I do. If our C is in the correct place, then the A and the B choice doesn't really matter. So what we're going to use the Pythagorean theorem for is when we have a right triangle and we have information about all the sides, whether that's numerical information or variable information, we're going to be able to start by focusing on that right angle, traveling to that opposite side, which is what we're going to call C, and then filling out this equation by plugging everything in. So in this triangle, C is actually x, so it's going to look like x squared equals. The a squared and the b squared, remember, are those other 2 sides. So one of them will be 6 squared and the other will be 8 squared. Totally fine if you thought about writing it down as x squared equals 8 squared plus 6 squared. Those are equivalent, so it doesn't matter which one you choose. And at this stage, we have to simplify the exponents that are on the numbers before we're allowed to do any of our other solving. So these are going to become 8 squared is 64. 8 times 8, or use your calculator. 6 squared, 6 times 6 is 36. These numbers are on the same side, so they're considered like terms. We can combine those together as they are. And then the reason we've been doing this radical simplifying stuff over here is because to get rid of this exponent on the x, we need to square root both sides of the equation. Now I'm going to suggest before you even start thinking about whether or not this simplifies, you write down an answer for x. That's important. So right now, this side simplifies to be x, and this side is the square root of 100. Now, even if something goes wrong in terms of making your way to an exact simplified answer, at least this line right here proves to your teacher that you know how to use Pythagorean theorem. So you can still get some of your credit if you always write down x equals and then this root with the number that's appropriate on the inside. From there, though, we are always going to try to simplify. So best case scenario, we type that root into the calculator and it gives us an integer answer back. So that means we're going to improve this answer and actually write it as x equals 10 to finish that problem. I just noticed after I drew that box in there that these are both labeled in feet. So that means my answer should be labeled in feet as well. So even though it's going to look a little bit weird, I'm going to go ahead and add that on there. They will always have the same units, the 3 sides, or they should always have the same units. All right, let's do that again. It all starts with making sure we identify that C carefully by traveling across from that right angle. So this side here is going to be the c this time, which means this problem might feel a little bit different than the last one because our c is a number instead of being a variable. We set it up the same way. C squared equals a squared plus b squared or a squared plus b squared. It doesn't matter. So I'm going to write 5 squared plus x squared. We still simplify these numerical expressions. So 10 squared, 10 times 10, and 5 squared, 5 times 5. And this time, our numbers aren't on the same side of the equation. So we're going to use our equation solving skills to subtract that 25 over, which leaves us with 75 equal to x squared, which is where those square roots are going to come in. And then remember, we're going to write down root 75 equals x, because at least we've shown now that we know how to do Pythagorean theorem and we got to an answer for x. Bring our calculator in, and the square root of 75 is not exact if we end up with a decimal like that. So that's where you're going to go with whatever method you prefer to try to simplify that root 75. If I use the table method, obviously 75 is not going to work. I can't divide 75 by 2, but I can divide it by 3. If I try to square root that larger factor, that's going to do it. That was quick. So that means the better answer for x is to square root the 25 to get 5, and then this root 3 multiplies by that to be equivalent to the root 75. So the simplified exact answer will be 5 root 3. All right, number 3, very similar to the 2 that we've done. Oh, I did it again. Kilometers. So kilometers for that answer. Sorry if I forget that in the future. All right, back to this one. Travel across from that right angle to find the side that's going to act as our c. So our setup here is x squared equals 15 squared plus 6 squared, or 6 squared plus 15 squared. X squared then, if we simplify 15 squared, it's 225 plus 6 squared is 36. Those are on the same side of the equation, so we go ahead and add those together to combine them, and x squared equals 261. We're going to square root, and we're going to write down x equals root 261 to prove to our teachers we know Pythagorean theorem, and then we'll work on the simplifying phase of this. Sorry for the glare there. Square root of 261, not lucky. We're going to have to work more diligently on that. So if you start thinking about the square root of 261, maybe I'll go ahead and do this one with the factor tree, just in case any watchers use factor trees. Let's see, could we divide 261 by, not 2 because it's not even, how about 3? Yep, 3 and 87. So 3 is prime, we don't need to worry about that. Can I divide 87 by 3? 3 is working nicely. Okay, 3 and 29. 29 is prime, so I think that's going to be it if we're a factor tree person. I'm noticing here I've got a set of matching 3 factors and a leftover 29. So that means the best answer, we're going to improve this a little bit, is that x is actually equal to 3 square root 29. So if we stopped here, we would show that we know Pythagorean theorem, but we wouldn't get credit for simplifying our answer and getting it to exact simplified form. I believe you can still get to a 2 if you don't simplify, but maybe to get beyond that to the 2.53 and beyond, we have to get to those simplified answers. All right, last one on this page. Looks a little bit different. I did it again, miles. But this one is going to be set up in a similar way. It's just going to have some more algebra. So there's our c. We're going to have x squared equals, and then we've got one side that's a number. I'm going to call that a, so 5 squared, plus this side also has x, but it's the quantity x minus 1 squared. Nothing to simplify over on the left side of the equation. 5 squared is 25, and then do you remember from our opening problems, when we have a binomial that's squared, we have to multiply that by itself. So we're going to end up with a lot of terms over here on the right side of the equation. X times x is an x squared. X times negative 1, negative 1x. Negative 1 times x again is a negative x. And negative 1 times negative 1 is positive 1. So if we start to clean this up a little bit, my biggest exponent is x squared. I'm going to write that first. It's on its own. Then I have these two terms here. A negative 1x minus another 1x is negative 2x. And then 25 plus 1 is 26. Okay, now this looks intimidating, but you have an x squared on the left and an x squared on the right. So if we try to subtract and get all those x squareds together, x squared minus x squared is actually 0. 0. So all that's left, this feels weird, is 0 equals negative 2x plus 26. No quadratics though. Regular x's, I'm going to add those to the other side real quick so that we've got our x's on the left and our numbers on the right, and then just a quick division by 2. And we don't even have to worry about square rooting for this one. Because of all that algebra, we didn't end up with any x squareds that required square roots. So x is just 13. I'm going to remember my units even though I drew in my box before I move on to the next problem. All right, go ahead and pause the video. We're going to move to page 2, and I'll meet you back here for a few more examples. All right, there isn't a lot that's new on this page compared to what we've already done. So if you'd like to pause the video and try them and then just kind of fast forward it to when each problem is done to check your answers, that would be a perfectly acceptable thing to do if you feel like you've got a handle on Pythagorean theorem. I'm just going to keep rolling here in case you were absent. So across from that right angle is C. That means I'm starting with x plus 1 squared in this equation. And then my a squared and my b squared are going to be x squared and 5 squared in whatever order I wish. Squaring a binomial means I need to take that x plus 1 and multiply it by itself. So if I write that out so I can see it, x times x is x squared. X times positive 1 is positive 1x. Got another 1 times x for another positive 1x. And then positive 1 times positive 1 is 1. Over on this side, I've got an x squared, and 5 squared is 25. Just like the last time, I've got some like terms. So if I combine those together, I'm going to have positive 2x on this side. And then just like the last time, I'm going to try to get these x squared terms on the same side, and they both make 0. But unlike last time, I still have terms left on the left and on the right, so I don't get that kind of strange equation where everything is equal to 0 like last time. So if we just subtract 1 from both sides and then divide by 2, we've got our answer here for x. No square rooting necessary again because those x squareds reduced as part of the solving. All right, number 6 here, there's my right angle, so if I travel across, 14 is going to be my C. 14 squared equals 6 squared plus x squared. 14 squared is 196, and 6 squared is 36. Since those are on different sides of the equation, I'm going to subtract 36 to leave me with 160 equal to x squared. And I'm back to needing to square root to be able to get an answer for x. So there's my answer that proves I know Pythagorean theorem. Now I see if it can be simplified. So the square root of 160 can't be simplified just by typing it in. So that means I'm using factor trees, factor tables, perfect squares, whatever we prefer, to try to show what this root is going to simplify to be. I did the last one with a factor tree, so I'm going to do this one with a factor table. 1 and 160, 2 and 80. If we try to square root 80, no good. 160 I don't think can be divided by 3. Nope. 160 divided by 4 is 40. So if I try to square root 40, doesn't work out. 160 divided by 5 is 32. Now I'm typing all of this in, but if you know your perfect squares, you'll know that square root of 32 is going to be a decimal. So you can just kind of keep going until you spot a perfect square. But if you don't know, you just keep trying them on your calculator. 160 divided by 6 is a decimal, so we don't use that. Divided by 7, divided by 8 is 20. Square root of 20 isn't going to work, but if you're not sure, you type it in and you see the decimal. All right, this is getting kind of irritating, but we divide by 9, that doesn't work. Divide by 10, oh good. 10 and 16. That's going to be it, because the square root of 16 is 4. So we're going to make this answer better by rewriting it as 4, this part simplified, root 10 equal to x. There's our simplified answer for the square root of 160. All right, last one on this row. Looks like it's going to be another opportunity to square a binomial carefully here. So we're going to have x plus 3 squared equal to 9 squared plus x squared. X plus 3 times itself equals 81 plus x squared. X times x times positive 3 times x, and positive 3 times positive 3. Combine those like terms, and just like the last two times, when I try to move that x squared term to make sure all the like terms are together on the same side, they make 0 on both sides. So we're left with a 6x plus 9 equal to an 81. Subtracting 9 is going to give us 6x equals 72, and x is 12. No square roots, so we don't need to simplify in that problem. All right, 3 to go. We're almost there. Right angle sends us across to that Pythagorean theorem C side that we need to be careful to have first. X plus 4 squared equals 8 squared plus x squared. Multiply that x plus 4 by itself. Equal that to 64, which is what 8 squared simplifies to be. X times x times positive 4, and then positive 4 times x, and positive 4 times positive 4. Gives us our 4 little multiplication answers on that side. Like terms here in the middle, so we really have 8 x's on that side. And if we subtract, sure enough, we're going to get 0 out of both of those x squared terms. So 8x plus 16 is left on the left side and 64 on the right. If we subtract 16, we'll end up with 8x equals 48, and x is 6. And I noticed while I was doing that problem that I forgot my units on all of these. So that one's kilometers, this one up here is feet, this one's kilometers, and this one over here is miles. That's a big triangle, measured in miles and kilometers. All right, 2 more. Travel across from that right angle. So this time our C is going to be x squared. A squared and b squared are both numbers, so 9 squared and 6 squared, in whatever order you want, get added together. 81 plus 36. Those are on the same side of the equation, so if we add those up, we're at 117. And I am remembering that we have already square rooted 117 once today. So in a second here, after I write down my answer that proves I know the Pythagorean theorem, in case I make a mistake, I'm going to revisit what we did at the beginning. The square root of 117 is 3 root 13. So I'm not going to go through that a second time, but you do need to show your work for your simplifying when you're taking your assessment. So just make sure that you recognize that you can't just write the x is equal to 3 root 13 without having something to show where that came from on your assessment. But we already showed the work for that on the other piece of paper. All right, finally, number 10, the last one of the day. Travel across from that right angle and find your way towards your C. 15 squared equals x squared plus 14 squared. 225 equals x squared plus 196. We need to take 225 and subtract away that 196, which is only going to leave behind 29, equal to x squared. And then if we square root, we're going to write down root 29 equals x, just so that we have an answer. And we'll see one last time if there's anything we can do, not with our calculator. Can 29 be divided by anything? If you're not sure, you're just going to have to start with small numbers and keep dividing. So I divided by 2 and 3, got decimals both times. If you divide by 4, you get a decimal. If you divide by 5, you get a decimal, but I know I'm done checking because there are no numbers between 5 and 5.8 to test. So that just means that this answer is as good as it gets. It's as simplified as possible. There aren't going to be any perfect square factors in 29 for us to simplify. All right, that's it for today. Hopefully this helps you understand Pythagorean theorem. We'll see you back here for the next one.